Hi everyone, thank you for joining me again. As promised, I said we'll be solving one of the questions on bending and twisting of shafts. And for this problem, I've chosen to take one of the old exam question papers. We'll solve it step by step. We'll first resolve all the forces that are acting on my shaft. Upon completion, we'll then move on and calculate the bending moments that are acting on my shaft. So for the first part, let's have a look. So this is the 2018 question paper. This was for the first trimester. And the question we're looking at was question 1, which had the following, or which read as follows. Okay, so the problem says, consider figure 1. F is a flywheel with a mass of 200. B is a driven gear. A is a driving pinion which transmits 40 kilowatts. So A and B are meshing together. So this pinion transmits 40 kilowatts from a motor rotating at 2,200 revs per minute. Pinion A has a PCD of 240 millimeters. The gear ratio between the two gears is 2:1. C is a flat belt drive. C is a flat belt pulley mounted at the extreme left and of the shaft and drives a machine situated below it. The PCD of the pulley is 500 millimeters and the angle of contact of the belt is 210. The coefficient of friction between the belt and the pulley is 0.3 millimeters. All dimensions are in millimeters. Okay. Alright, so let's have a look. So I've taken the liberty to draw this on a mascara diagram, and let's have a look what we have been actually given. Okay, so we've been told that the flywheel F has a mass of 200, which will obviously be acting down. It will have a weight acting down. We've been told that the gear B is the driven gear, and it is driven by gear A. Right? And this gear A is transmitting 40 kilowatts. The speed of the motor which is coupled to my gear A, is running at 2,200 revs per minute. We're also told that the PCD of gear A, here we've got the PCD, that is 240 millimeters. We were also told that the power transmitted by the motor is 40 kilowatts. So power transmitted here by the motor is 40 kilowatts. The gear ratio between these two gears will also give it. Here's my gear ratio is 2:1. And then they were also told that pulley C is a flat belt pulley mounted at the extreme left. So this is my pulley. And this pulley drives a machine situated below it. The PCD of the pulley is 500. So here we're given the PCD of the pulley as 500. The angle of contact of my belt to my pulley is 210 millimeters. Alright, so the coefficient of friction between the belt is 0.3. All dimensions are in millimeters. So this is my line shaft as shown over here. So we now need to resolve the forces that are acting on my shaft. Now, the simplest of them all to solve would be to start with the flywheel. Right, so let's start with the flywheel. So my flywheel has a mass of 200. Okay, so yeah, flywheel has a mass of 200. Therefore, it will obviously have a weight which is acting downwards on my shaft. So that weight will be nothing but the mass times the gravitational acceleration. So it's 200 times 9.81. If you calculate that, so it's 200 times 9.81, you get 1962 Newton. Alright, so that is the flywheel. Okay, so let's move next to the pulley. So if you look at your pulley, uh, here they gave me the manner in which my pulley drive is situated. And as depicted on my picture, I was told that my pulley belts are at an angle of 30 degrees to the vertical. So the angle there is 30 degrees. So this is T1, this is T2, and obviously my pulley is mounted on my shaft right over there. Okay, so my pulley is mounted on my shaft. Then I can say that the total tension acting on my shaft will also act at an angle of 30 degrees. So the total tension here will be T1 plus T2. Alright, so then I need to now find my two tensions, T1 and T2. So how do I find those tensions here? Alright, so remember that we were given the power from the motor, which was 40 kilowatts. But that is the power here at A. Alright? What I need to do is I need to calculate the torque on my shaft. So this is the shaft that I'm interested in. But from this formula here, okay, let's just move that up. Yeah. From this formula, power is equals to 2 times pi times n times the torque divided by 60. Alright, since I have the power and this power is from the motor and my motor is fitted to gear A, so here I will have 40 times 10 to the power 3 kilowatts, 2 times pi times the speed of the motor times the torque. This will be the torque on my gear A divided by 60. So what is the torque at A? So if we calculate the torque at A, let's do a quick calculation here. So this will be 40 3 times that by 60. Divide all of that by 2 times pi times that by 2200. Alright, so we get a torque of 173,624 Newton. So, but this is the torque on here, on the shaft, which is fitted to my motor, which is driving gear A. I'm looking for the torque here, not there, here. So, I was given the gear ratio between these two gears. Now, since my gear A is the smaller gear and B is the bigger gear, obviously B will be turning much slower than gear A, which would mean that if it's turning slower, you require more torque to turn it. So it would be obvious that the torque at this shaft since the gear ratio is 2:1, the torque here will have to be double the torque over there. So this torque right here at A, I will have to multiply by 2 to find the torque at my gear B, which is the one which is fitted on my shaft. So multiplying this by 2, let's see, times 2. Alright, so this gives me an answer of 347,247 Newton meters. Ah man, this is Newton meter. Torque. Torque is Newton meters. So this is the torque on my gear B, and gear B happens to be fitted on my shaft. So it would mean that now the torque over here, the torque on this shaft here, would then obviously be the torque at B. So the torque over here is the same. So therefore, I know what the torque at B is. We have calculated it there. So now I can come now and say, all right, since my torque, the torque on my pulley, is nothing but the tension at 1 minus the tension at 2 times the radius of my pulley. All right. Before we establish this formula, we need to find the tension ratios between my two tensions. So the tension ratio is given as T1 over T2 equals to E exponent coefficient of friction times the angle of contact. Now, this is T1 over T2, which is equals to E. The coefficient of friction, if you remember, I was given as 0.3. That's the coefficient of friction between the pulley and my belt. Okay, there is it there. The angle of contact I was given as 210. But this angle of contact would need to be in radians. So we have to multiply that. So this angle of contact here, we'll have to multiply by pi over 180 to convert it to radians. Alright, so when we calculate here, we have the following. Okay, so it's 0.3 times that by 210, multiply that by pi, all of that over 180. That gives me this, so this is to the pi that. So my tension ratio here I get as T1 over T2 is actually equals to 3. So I can say that T1 is 3 times the tension at 2. So now that I know that T1 is 3 times the tension at 2, I can now go back here to my formula here, okay, and say that, alright, my torque at my pulley, remember the torque at the pulley, we calculated it here, it's this torque here, 347. So I can quickly write that and say 347, 247. This is equals to the tension at 1 is 3 times T2 minus T2 times the radius of my pulley. Remember the diameter of the PCD of my pulley I was given as 500. So this is 500. So this is the PCD. So therefore the radius will be half of that is 0.25. So here it is 0.25. 0.25. So to find my tension T2, it will be nothing but just solving that equation there. So 3T2 minus T2 gives you 2T2. Alright. So let's have a look here. So it's 347.247 divided by 0.25. Divide this by 2. So for my tension T2, I get 694,494 newtons. So therefore my T1 will be three times that from there. So multiply this by 3, we get T1 is 2083,482 newtons. So now I've found my two tensions over there. Now I know now. Now I can go back now and say, alright, since I know my two tensions, so I know the tension here and I know the tension there. If I add these two tensions, I'm going to get a total tension which is acting on my shaft. Then, obviously, to find my horizontal and vertical force which are acting on my shaft, then it would mean that I would have to add the two tensions, correct? I would have to add the two tensions, and then once I've added the two tensions, I'll need to resolve my total tension into horizontal and vertical forces. So this would mean that I would have a vertical force acting downwards, and I will have a horizontal force acting to the left. If I just draw, let me just draw that in dotted line here. So my horizontal force would be there. So if I add T1 plus T2, remember T1 plus T2, so let's add this one. So I've already calculated T1, so plus 694.494. Okay, so let's just do that again. So it's 2083.482 plus 694.494. Right, so the total tension here is 2777.9. So let's make this 2778. So it's 2778 newtons. Okay, 2778 newtons. So what do I now know now? I know the following now. I can say, alright, that is my tension there. So this is the actual triangle that I have. I've got my total tension acting at an angle of 30 degrees. So I'll have my vertical force going down and I'll have my horizontal force going to the left. So this is 2778. So to find F horizontal and F vertical, I would say that F horizontal would equals to 2778 sine 30 degrees. So if I calculate that, 2778 sine 30 degrees, that gives me 1389 Newton. And then if I calculate my other force, vertical force, F vertical, that will be 2778 cos 30 degrees. That gives me 2778 cos 30 gives you 2405.82 Newton. Okay, alright. So I've resolved my forces on my pulley. Okay, so on my next video, remember we've got one last component to solve, and that is the gear. So in that video, we'll solve the forces on my gear, and then we'll start calculating the bending moments on my shaft.